AI is getting smarter. That part is true. But smarter doesn't mean more honest. And I think that's the most important thing to understand right now. Here's what most people assume. If an AI can solve graduate-level science questions, it probably doesn't make things up. That sounds reasonable. If something is smart enough to reason through hard problems, surely it's grounded in real facts. That's the assumption. And that assumption is wrong. Confirmed wrong. The data from mid-2026 makes that very clear. Let me explain what's actually happening. By mid-2026, every major AI lab has built what are called reasoning models. OpenAI has them. Anthropic has them. Google DeepMind has them. xAI has them. The idea behind a reasoning model is simple. Instead of just answering immediately, the model takes extra time to think through a problem step by step before giving you an answer. More thinking time. More computation. More steps before the final response. And on certain tests, this works incredibly well. Google's Gemini 3.1 Pro scored 94.3% on something called GPQA Diamond. That test measures graduate-level science reasoning, not basic science. Graduate level. The kind of questions that would challenge a PhD student. Gemini got 94.3% of them right. That's a confirmed score from the Team AI benchmarks published in June 2026. OpenAI's GPT 5.4 scored 83% on something called GDP-Val. That test measures how well a model handles real-world economic tasks, not theory, real tasks. And 83% is a strong result. So the numbers look good. The models are clearly reasoning better. I get why people look at scores like that and think, these systems are incredibly capable. They are. On those specific tasks, they really are. But here's where it gets uncomfortable. Vectara ran an independent hallucination benchmark in May 2026. Vectara is an AI research group that specifically tracks when AI models make things up, state false information with confidence. They call this hallucination. And what they found is this. Every single reasoning model they tested had a hallucination rate above 10%. Every one. 10% means 1 in 10 responses contains made-up information. Not a guess. Not uncertainty. Confident, wrong information presented as fact. That's what hallucination means in this context. The model says something that isn't true, and it says it like it knows. Now here's the part that really got my attention. Simpler, faster models, the ones that don't do all this extra reasoning, scored as low as 3.3% on the same hallucination test. That's less than a third of the hallucination rate of the smarter models. I'll say that again because it matters. The less advanced models lied less. The more advanced reasoning models lied more. 3 times more in some cases. This is confirmed data from the Vectara Hallucination Leaderboard, May 2026. The field actually has a name for this. They call it the reasoning accuracy trade-off. And I think it's worth understanding exactly what that phrase means, because it's not just jargon. It describes a real mechanical problem inside these models. When a reasoning model works through a problem, it doesn't just retrieve a fact, it builds an answer. Step by step. It constructs a chain of thinking. If this, then this, which means this, so the answer is this. That process can lead it to correct answers on complex problems, but it can also lead it down paths that feel logical but aren't grounded in anything real. The way I understand it is this. Imagine you're solving a puzzle with pieces. A reasoning model is really good at connecting pieces in ways that look complete. But if one piece is slightly wrong, or if the model fills in a missing piece with something it invented, the whole structure looks fine from the outside. Confident, complete, wrong. A simpler model doesn't do as much building. It retrieves more and constructs less. That limits what it can do. It won't pass graduate-level science tests, but it's also less likely to confidently invent something that doesn't exist. That's the trade-off. More reasoning power, more hallucination risk. And I want to be clear, this isn't theory. This is what the benchmarks show, confirmed by independent testing in May 2026. Now let me give you some specific models so this stops being abstract. Claude Opus 4.6, built by Anthropic, was tested on GPQA Diamond. It scored very high on the science reasoning tasks. Impressive results. But it also showed up in the Vectara hallucination data with a rate that puts it in that over 10% range. High capability, high hallucination risk. That combination is what the data keeps showing. Gemini 3.1 Pro, the same model that got 94.3% on graduate science questions, is in the same situation. Strong benchmark performance. Meaningful hallucination rate. Both things are true at the same time. That's what confuses people. We're used to thinking that a smart person who gets hard questions right is also trustworthy on everyday questions. But these models don't work that way. Their strength on hard reasoning tasks doesn't protect them from making things up on factual ones. To me, this is the key confusion that's spreading right now in 2026. People see AI score 94% on a science test, and they think, this thing knows what it's talking about. They use it to research a medical question. They use it to check a legal fact. They use it to get background on a news event. And 10% of the time, or more, they get something wrong that's presented as right. That's a real-world problem. It's not a lab problem. Here's why the gap exists at a slightly deeper level, because I think it's worth knowing. Reasoning models are trained and evaluated heavily on tasks where you can check the answer. Math, coding, science problems with known solutions. The model learns to reason through those specific structures really well. That's what it's been rewarded for. But factual accuracy, knowing whether a specific claim about the real world is true, is a different skill. It requires the model to know what it doesn't know, to say, I'm not sure, instead of building a plausible-sounding answer. And that second skill isn't what the reasoning training optimizes for. The current theory in the field, based on the SurePrompt's reasoning model breakdown from May 2026, is that the extra computation these models use actually increases their confidence in wrong answers. They don't just guess and move on. They reason their way to a wrong answer. They build a case for it. And that case feels convincing, to the model and sometimes to the user. That's different from a simple model that hedges or gives a shorter answer. The reasoning model commits. I find that genuinely concerning. Not in an alarmist way, but in a practical, everyday way. Because the people most likely to trust a high-scoring AI model are also the people who don't know they should double-check it. So what does this actually mean if you use AI tools? The data suggests this. For complex reasoning tasks, working through a logic problem, debugging code, comparing options, reasoning models are strong. That's what their benchmark scores measure, and they do it well. For factual questions, dates, names, statistics, quotes, medical information, legal details, the hallucination data says, be careful. The more capable the model, the more confident it sounds. And confidence is not accuracy. That's the main thing I keep coming back to. The Vectara benchmark also found something worth noting. Hallucination rates aren't consistent across topics. Some areas are worse than others. Specific factual claims, exact numbers, citations, recent events, tend to produce more hallucinations than general reasoning. So a model can correctly walk through how a scientific process works and then give you a wrong publication date for the study that proved it, in the same response. That's a confusing experience for a user. Part of it is right, part of it is made up, and there's no clear signal telling you which is which. I think the honest conclusion here is that 2026 AI models are genuinely impressive at certain things and genuinely unreliable at others. And the problem is that both things are happening inside the same system, in the same response, sometimes in the same sentence. The labs know this. They're not hiding the hallucination data. Vectara publishes it openly. The researchers talk about the reasoning accuracy trade-off in their own papers. This isn't a secret. But it's also not what gets highlighted in the product announcements that say 94.3% on graduate-level science. What I found interesting in the research is that some labs are now working on ways to separate these two capabilities. Build a model that reasons well, but also knows when to say, I don't have reliable information on this. That's technically hard. Knowing what you don't know is actually one of the hardest things to build into a system that's been trained to produce answers. Some early approaches involve what researchers are calling grounded reasoning, where the model is forced to tie each step of its reasoning to a specific source it can actually point to, rather than building answers from internal pattern matching alone. Whether that solves the problem is still unclear. The current data says we're not there yet. It's also worth knowing that this problem isn't new. Earlier AI models also hallucinated, but reasoning models made it sharper because the gap between benchmark score and factual reliability is now so large that it's hard to ignore. A model that scores 94% on hard science and hallucinates 10% of the time on facts is a strange thing to communicate to people. The numbers don't fit the story most people expect. The story most people expect is, higher score means more reliable. The data says, not necessarily. These are measuring different things.